So what we get from a slope is we can now write a slope-intercept form. We had intercepts where we had the x-intercept, which was the point where the line crosses the x-axis. So the y value was equal to 0. And we had the y-intercept, which is the point where the line crosses the y-axis and the x value equals 0. Well, we can take a line and write it in terms of slope and the y-intercept. And so what we say is the y value is equal to the slope times the x value plus the y-intercept. And so we call y-intercept b. Right? We're going to call y-intercept b. It's just a standard way of talking about this. And so if we write our lines in this format, if we get the y on the left-hand side, functional form, we get a proportionality in x, we can shift it by the intercept, and we can always write a line. And this will let us describe every single line. And what we can do is define any line that we had using these two things, slope and intercept. Slope and intercept. So you usually need two pieces of information to make something. And in the case of lines, slope and intercepts are really good things to use. So let me make a axes down here. I'll make these blue, I think. Okay. I'll scroll down a bit. There we go. And we'll look at what we can do with slope-intercept form. I'll put the slope-intercept form here. So what we can do is always generate this equation, right? If you talk about any point being x comma y, and the other point being the intercept, the y-intercept, which is when x is 0, and we're giving it the value of b, well, we can use the slope equation, m equals the difference in y's, y minus 0, over the difference in x's, x minus y minus b, sorry, get my y's right, and x minus 0. So if I cross multiply, so m, well, let me solve this here, y minus b, started this out and didn't say it clearly, but there we go. So when x minus 0 is x, I'll cross multiply mx equals y minus b. But I want to do it so that I have a y equals. So I'll add b to both sides. Y equals mx plus b. So having 2 points and putting those points in the slope-intercept form will always give us a form, or putting those 2 points into a slope will always give us the form of equation that we need. For the case where the one point is any xy value and the other is the intercept, we define the intercept and we can get our equation. But that's right here. So what does this look like? Well, we have y equals negative 2/3 x minus 5. Now this is in slope-intercept form. Why is it? Well, I have y on the left-hand side. I have something times x minus or plus a constant. So I know that my slope I'll put it up here. M is this part here that's in front of the x. The slope is negative 2/3. And the intercept is negative 5. So this is telling me if I go 1, 2, 3, 4, 5 on the y-axis, this is my B part right here. 1, 2, 3, 4, 5. Negative 5 on the y-axis is where this line here, negative 2/3 x minus 5, intercepts the y-axis. That's what the y-intercept does. Now I have a slope of negative 2/3. So if I go up 2, I have to go back 3. 1, 2, 1, 2, 3. It's about here. Sorry, that line's a little off. And if I go down 2, 1, 2, I have to go over 3. And so that's my line. Drawing freehand, didn't have my ruler here, so it's a bit scrubby. And that's the process of what this form really nicely lets us do. It lets us draw the line quickly. But if we practice this with these, we could look at the equation and we can say, it's got a negative slope, so it has to be higher on the left, lower on the right. Well, that slope is fractional, 2/3. So for every 2 it goes down, it goes over 3. So that's what the slope helps us tell. The sign of the slope tells us if it's falling, because it's negative, or rising if it's positive. And then in this part here, tells us where it crosses the y-axis. So we get a vision of what our equation is doing by having it in this form. So we're going to spend some time working on getting it into this form so we can visualize it. What I want to do right now is I'm going to pull up another piece of software in another video called Desmos. It's a free online graphing calculator. I want to show you how to just draw lines using that so that when we do these exercises, you get used to doing it by hand, and so that you know what the slope means and the intercept means, that you can also have a tool for checking yourself. Because as you're learning these things, you make small sign errors, you might get your slope a little wrong, and things might not look right. Well, it's good to be able to double check that as you go. So, in the next video, I want to show Desmos' graphing utility and how to enter a line. But using the slope-intercept form, all the information we need comes from the two numbers. If we have it so that there is the slope in front of x, let me use bright red here. I'm changing to bright red. There we go, there's my bright red. All right. So if we have the slope in front of the x, the m, and some constant b is the intercept, we can go, there's the intercept, and then you can count out the points using the slope. That's the beauty of this technique. So next video I'll show you how to use a free online graphing calculator, and then we'll do some homework assignments where we start playing with this so that we can take a linear equation, get y on one side, everything else on the right hand side, and this form will let us see the line from the numbers. So we'll get a visual representation of it, and we'll draw those so we can see how the function is moving, because this motion tells us if my x value is small, right? Small x values have larger y values for this function. That's what a negative slope does. An intercept tells me where it crosses and points. And so we have to get used to seeing these as things, because what equations end up telling you is if I give you some x value, what do you expect the y value to be? That's what we're going to use it to predict for. And so shape is really important. Seeing it's really important at this point.